Welcome back to my series of videos on Calculus BC. This is from the Kennedy book, section 9.2, and the section is about Taylor series, but this video in particular is about memorizing the Maclaurin series. You need to make sure you memorize the Maclaurin series so that you can just rapidly pull them back as you need them, so you don't have to work really hard for them. So let's go ahead and get started with the most obvious one. That's 1 over 1 plus x. And the key to that is just remember that that is simply is just a geometric series where the ratio is equal to x. And so this is 1 plus x squared plus x cubed, so on. All right, and of course, what you need to remember from that is that the sum of a infinite series is 1 over 1 minus a. And so you keep that straight, and you'll be able to remember this one. All right, let's go on to the next one. All right, so 1 over 1 plus x. Well, that's simply the same series as above, where we've put negative x in place of x. So this ends up being 1 minus x plus x squared minus x cubed plus x to the fourth, so on. All right, so that's 1 over 1 plus x. All right, the next one. Now, we went over this before, but if you were to integrate both sides of this, and technically we should integrate this from 0 to x and do that of both sides. And of course, at that point, we have the wrong variable in here. We'd have to change these to t's, this to a t, and these to a t's. But really, all you need to remember is that you integrate both sides of this. The constants will be taken care of by integrating from 0 to x of 1 over 1 plus t. And we'll just take the integral of each of these. So the integral of 1 is x. The integral of negative x is negative x squared over 2. And then plus x cubed over 3. And minus x to the fourth over 4. And you begin to see the pattern. This ends up being x to the n over n. So that's ln of 1 plus x. Now this next one is 1 over 1 plus x squared. Now that's not actually one of them that they show that you need to have memorized, but if you have it, it helps us produce our next one, which is for arctan. So all we do to get this is put x squared in place of x in this function up here. So again, it's 1 over 1 plus x squared, so the first term stays the same. 1 minus x squared plus x to the fourth minus x to the sixth plus x to the eighth, and so on. All right, so that gives us 1 over 1 plus x squared. And the whole point of that is if we integrate both sides of this, the integral of 1 over 1 plus x squared is arctan of x. So then we can take the integral of this one, and we'll get x minus x cubed over 3 plus x to the fifth over 5 plus x to the seventh over 7. And you can begin to see the pattern here that we're actually, if this is n equals 1, and then this is n equals 2, n equals 3, we actually end up being, I think, 2n minus 1 for the exponent and also for the denominator. All right, so that's arctan. Now the next one is to help us produce e to the x. Now we need to remember the general form of the Taylor series. And remember that's f of 0. And actually remember this is a Maclaurin series which is a Taylor series centered at x equals 0. So we need to do f of 0 plus f primed of 0 times x over 1 factorial, f double primed of 0 times x squared over 2 factorial, so on. Okay, so that's the general form. So if we're trying to find the Maclaurin series for e to the x, remember the derivative of e to the x is always e to the x, no matter whether it's the first, second, third, fourth derivative, so on. So when we plug 0 in for each of those, the function itself, the derivative, and so on, each of those end up being 1. So you can just look at this general form of it, and instead of putting in the f of 0, f prime of 0, they just become 1s. So we end up with 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. And we have a really simple pattern. In fact, that's one of the easiest ones. Right, so that's e to the x. Next is sine of x. Now, sine of x actually takes a little bit of thought. Again, you could take the derivatives and you get that pattern of each derivative ends up being either a sine or a cosine, and either positive or negative. So what I like to remember is that the first term is f of 0. So the sine of 0 is, of course, 1. So sine of 0 is 0. And so the next one, and actually come back to this. If you graph sine of x, so we're going to graph sine of x here. And it's just a really ugly version of it. But now let's draw a tangent line there. So if I draw a tangent line at that point, apparently I have black ink here. Didn't mean to do that. Let's go for an orange one. We draw a tangent line. That is the line y equals x. So then that can remind you that you're starting off with x, and then plus, and then remember that the odd terms, so it's actually x minus, let me back that up there. Clean this up, I made a mess. So that's x minus x cubed over 3 factorial, and then plus x to the 5th over 5 factorial, minus x to the 7th over 7 factorial, and so on. So you can see the pattern there. All right, and then meanwhile, cosine, it's actually the easiest of these, because as I started to say on this one where I misspoke, the cosine of 0 is 1. So you actually start off with 1, and then they're all the even powers. So 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. And we have our sequence here. All right, now what I did in this video is I actually didn't give us a, didn't really give you a way of memorizing the nth term and the sigma notation. But with the pattern, you should be able to always figure those out. So make sure to study those, and make sure you know all the Maclaurin series. Thanks so much for listening, and I hope you do great on the AP exam.